Hey everyone, it's Dale with the Kindergartner's Guide. I help turn 5-year-olds into math mavericks. In this video, I want to share with you the streamlined process for turning your math learner into a math super talent. See, I believe that with the use of just a few simple techniques, any normal kindergarten age child can quickly advance to a 4th or 5th grade level in math ability and beyond. Now, quick disclaimer. This is obviously not going to turn your little Dee into a math sensation in a single day. It is going to take effort. But if you're consistent, your math learner can skip years of traditional math schooling and quickly become a very proficient arithmetician. So, what exactly is the formula for learning arithmetic quickly and confidently? The techniques lie in the letters of chain. C-C-H-A-N. Chain stands for counting, comparing, having and doubling, adding and subtracting, and naming. Now, let me explain what each of these techniques means and how they help students develop the core competencies of arithmetic. By the way, more on core competencies in another one of my videos. First off, counting. Counting is the sequential naming of intervals. See, at a very early age, we, human beings, learn to count by ones. This is what puts our numerical system into context for the budding mathematician. But counting goes much further with not just counting by ones, but counting by other intervals as well. Just as counting by ones gives us perspective on whole numbers and place value, counting by multiples, fractions, decimals, percentage, or logarithmic factors puts numerical relations, syntax, and operations into greater perspective. For example, in the Kindergartner's Guide to 5th grade math, we learn to count by 1/4 in decimal terms. Starting at 0, those would be 0.25, 0.5, 0.75, and 1. This exercise puts decimals into context specifically as it relates to whole numbers. We start with counting from 0, naming 4 intervals of 0.25 until reaching 1. Now, it may take your kid a few tries to get this down, but once she does, she rarely forgets it. A bit later, we try counting up to 2 or more, and then we progress to other starting numbers such as starting at 53, counting up to 60, just for example. This technique gives a math learner a profound perspective on decimal syntax, numerical indexing, and practical application of operations. Next is comparing, which means we identify attributes of values and relate them to others. Attributes include bigger, smaller, and how many. We include how many because it presents an initial value to the student and asks them to relate it to another value comparatively or as a proportion. This is probably the most overlooked and underappreciated skill subset in the entire range of arithmetic. With the ability to identify and express the relationship of objects, we unlock the door for deeper numerical awareness and operational function. For example, we ask, how many times does 4 go into 32? Since we have previously covered counting by 4s, your student counts up to the value of 32, which produces the complementary factor of 8. Your child knows this easily because she has 8 fingers up when she gets to 32. So ultimately, this and other exercises help students understand factorization theory, which is reducing large numbers down into their smallest whole number components. Having and doubling takes us one step further by expanding on the ideas of comparison using a natural human ability to identify and produce the ideas of symmetry. With this, we are able to perform complex operations with simulated constructs. For example, the notorious 8 times 6 is simply 4 times 6, or 24, doubled for 48. Likewise, the student can take the multiple of 48 and reduce it to a factor of 6 by cutting 48 in half 3 times, 24, 12, and 6. The other factor is immediately known to be 8, since cutting a number in half 3 times always produces a factor of 8. Adding and subtracting takes next stage, which brings the previous 3 sections of counting, comparing, and having and doubling into higher focus. Adding and subtracting simply means putting values together or pulling them apart, but not necessarily with factors. For instance, for the value 10, we know it can be broken down into its whole number factors of 1, 2, 5, and 10. These are all whole numbers that go evenly into 10. But we can also break 10 into the sums of 3 and 7, or 9 and 1, just to name a couple. Now, some folks are surprised to see us cover addition and subtraction concepts after multiplication and division. So what I discovered is that addition and subtraction in many ways is harder to grasp and takes more mathematical interdiscipline than multiplication and division. Now basically, the concepts of multiplication and division are more naturally understood by a young child than addition and subtraction. This is due to the fact that we, again as humans, have an innate concept of modularity and serialization. In other words, things that happen in regular order. This lends exactly to multiplication and division. In fact, counting by ones is actually the act of multiplying a 1 unit by a factor of a 1 unit greater at each successive interval, or module. One of our first mathematical routines in life. Lastly, we tie the previous 4 sections together with naming. Naming is the formal expression of mathematical concepts, methods, and syntax in the verbal and written forms, which we're all familiar with from grade school. Now, the reason why we do this last is to focus intently on the concepts and methods prior to formalizing those concepts into math speak. See, I truly believe that students actually have a much better chance in comprehending mathematical concepts if we hold off on all of the complicated syntax, needless terminology, and rote process for as long as possible. This lets students visualize and construct a natural awareness of relationships and to think of math dynamically and creatively. In the real world, it means your student could answer, what is 5 divided by 4? A pretty difficult question for the average 5-year-old. She gets the answer of 1.25 pretty quickly because 5 divided by 4 is just 5/4 or 5 counts of 0.25. So there you have it. The actual formula for turning any normal 5 or 6-year-old into a young math master. Now, as with any recipe, the ingredients are only half of what you need to turn out a beautifully crafted creation. The other half will involve putting those ingredients together in specific ways to bring together a souffle of arithmetic fluency. That is where we come in. The free videos on this channel take you step by step into each of the 5 math building techniques. The routines are easy to learn and only take about 2 minutes to practice, mostly during free moments throughout your day, such as at the car wash, during checkout at the store, or just walking home from school. So check out the amazing content on this channel and hit that subscribe button to get daily and weekly exercises, tips, and math hacks for turning your youngster into a math champion. As always, thanks so much for watching, and until next time, this is Dale with the Kindergartner's Guide, helping your math learner get a rocket launch start in math. See you later.